What happens when a signal enters a system and comes out looking different? In real communication systems, signals are often modified unintentionally as they travel through circuits, channels, and devices. These unwanted changes are known as signal distortion, and understanding them is essential for every RF engineer. In an ideal world, every system would reproduce its input perfectly. A transmitted signal would arrive at the receiver exactly as it was originally generated, preserving all information without any changes. Unfortunately, real-world systems rarely behave this way. As signals pass through amplifiers, filters, transmission lines, antennas, and wireless channels, different frequency components may experience different levels of attenuation, delay, or phase shift. These effects can alter the shape of the signal even when the information itself remains present. The challenge for engineers is understanding why these changes occur and how they affect communication performance. To solve this problem, we must study the concept of signal distortion. Signal distortion occurs whenever the output signal differs from the input signal in an unintended way. The signal may still contain the original information, but its shape, amplitude, timing, or spectral content has been modified by the system. Distortion can arise from many causes. Some systems attenuate certain frequencies more than others. Some introduce delays that affect different frequency components unequally. Others exhibit nonlinear behavior that generates entirely new frequency components not present in the original signal. The important distinction is that distortion changes the signal itself, whereas simple amplification or attenuation only changes its overall level. Distortion alters the relationship between different parts of the signal and can therefore impact information quality. Intuitively, imagine photocopying a document multiple times. Each copy may still be readable, but small imperfections gradually accumulate. Lines become blurred, edges lose sharpness, and details may disappear. Signal distortion works in a similar way by altering the original waveform. Physically, consider a square wave passing through a low-pass filter. The filter attenuates higher frequency harmonics that are responsible for the sharp edges of the waveform. As a result, the output no longer looks like a perfect square wave, and instead appears smoother and more rounded. Mathematically, distortion occurs when different spectral components are modified differently. Since complex signals are built from many frequency components, unequal treatment of those components changes the overall waveform shape when they recombine at the output. Signal distortion is a major concern in RF engineering because communication systems depend on accurate transmission of information. Excessive distortion can increase bit error rates, reduce signal quality, and degrade overall system performance. In wireless communication, distortion may arise from multipath propagation, limited bandwidth, amplifier nonlinearities, or imperfect filtering. Engineers must identify and minimize these effects to ensure reliable operation of communication links. At the system level, distortion influences transmitter design, receiver architecture, modulation schemes, equalization algorithms, and channel compensation techniques. Managing distortion is one of the key challenges in modern communication engineering. Not all distortion is equally harmful. Some forms may have only a minor impact on system performance, while others can completely destroy transmitted information. Engineers therefore focus not only on detecting distortion, but also on understanding its severity and consequences. A common mistake is assuming that any change in signal amplitude constitutes distortion. In reality, a signal can be amplified or attenuated without being distorted, provided all frequency components are affected equally. Distortion occurs when the signal structure itself is altered. The study of distortion naturally leads to sampling and digital signal processing concepts. Once engineers understand how systems can alter signals, they can explore how signals are converted into digital form and reconstructed accurately for modern communication applications. In this lesson, we learned that signal distortion occurs when a system unintentionally changes the shape or structure of a signal. We also saw how filtering effects, frequency-dependent behavior, and nonlinearities can alter signal quality and impact communication performance. In the next lesson, we will explore the sampling theorem and discover how continuous time signals can be converted into digital signals without losing information. If you found this useful, like the video, subscribe, and follow for the next lesson.